Hello, we are Alessandro, Moses, and Lubomir. We are tackling challenge number 1. The challenge aims at developing an automated workflow that inputs data hazards by the health and safety manager. Each construction site has its own unique sets of risks, and health and safety managers are designated to mitigate those. The output will be a power app that captures the data directly from site and links to the streamlined workflow. The benefit of this solution is a reduced risk of incidents happening to the workforce, as well as a reduced time in which risks and hazards are being communicated with the wider team.
So, to tackle the challenge, we created user stories at different point of views of the problem. On one side, the health and safety manager wants to increase the awareness of possible hazards on site to keep the workforce safe. On the other side, the digital construction manager wants to visualize hazards types and location to improve the team communication. The workflow starts from the need of a health and safety manager to keep informed the site's operatives of live hazard in the construction site. Through the deployment of an electronic form, the health and safety manager can associate hazard information for each room and space in the project. After the relevant information has been produced, the forms are synchronized on the central project database, and the digital construction manager will receive a notification. After that, he will import the hazard information in the 3D authoring software, and the next step is to upload the 3D model to the project 3D viewer, so health and safety managers and operatives can visualize the hazards. As the construction site is a dynamic environment, new room layouts will need to be created to reflect the ongoing works so the electronic form can.
Welcome to the demonstration of our working app. In this instance, we are looking at the college under construction, and the health and safety manager is currently on the walkout to understand what are some of the risks posed to the workforce on site. Once he identifies the risks and the areas, he opens the app and searches for specific rooms that he requires. In this instance, he noticed that the room 220, which is an electrical room, will require work permits. He therefore informs that there is a prohibition within this area and notifies that work permits are required, but there is live electricity. He confirms this. As he confirms this, the digital construction manager will receive an email that changes have been applied and the BIM models need to be updated. Once this email has been received, the digital construction manager knows that there are changes that need to be applied to the BIM model. Because the Power App is linked to a OneDrive SharePoint file, we can access this file directly from the software themselves and link the data live. This is done through an internal automated system that links the specific SharePoint data that has been produced from the Power App. Once this has been completed, then the model can be uploaded to the cloud service for the site team to view it live. Once the BIM models have been updated, the site team has access now to the latest information about the risks on site. If we have a look at a closer presence of some of these objects, we can see that cubes are present, identifying the prohibition and the permit to work requirement highlighted by the health and safety manager. This process, from identification of the hazards and infilling the form to actual upload to the cloud, takes about 15 and 20 minutes, reducing significantly the amount of time it takes between the risk identification to the actual information of site-wide team.
The main limitations of our solution are mainly two. The first one is that the data produced within the Power App form is not linked and stored within a server. The second one is that manual input is still required when linking the database and Dynamo together, and when uploading the 3D model from Revit to the online viewer. We can identify 4 future improvements areas. First one, the construction plan will be linked to the app to facilitate the 3D model geometries and room creation. The second one could be that QR codes are associated to rooms and facilitate the population hazard information from the operatives. The third one could be that pictures of hazard would be loaded into forms. For example, no access zones or confined space pictures. And the last one, it could be that severity risk input from Power App could trigger a second workflow that will require an approval or further supervision. This was our presentation. Thank you for watching. The 3D Viewer will be an online-based tool that has a mobile app that can be downloaded on a mobile device. Internet connection will be an essential part of keeping the models updated on the tablet. However, when the update process is completed, the app will work without internet connection if the site is in a remote location. The project will provide tablets and mobile devices for operatives and visitors. Providing this access on corporate device will keep the project information safe and as access control will be implemented. On the other hand, if visitors want to use personal devices, access to the app will have to be sorted ahead of the visit. However, this is not advisable as it leaves unmanaged access to the project and it will require further work to remove the access after the visit.
I think the scalability of the solution is very linear. Each construction site will have access to their own Power App with their own SharePoint as a main point of source of the information. But going forward, these SharePoints, I believe, would be replaced with SQL Server or just any server really. That could then link multiple construction sites. The access to this information is fairly streamlined as it currently stands, but the real power would come out of joining these different construction sites, joining these different databases of risks that have been raised, and analyzing them in the same point of source.